How are you? My name is Caleb, and I want to present to you the topic on linear motion as per the Kenyan syllabus Form 3 class. Linear motion is the first topic of the physics syllabus. Then we have about 10 topics, but now we are going to concentrate on the first topic, and we want to learn a few things on this linear motion as our lesson 1. So to start with, we want to see the lesson objectives. By the end of the lesson, the learner should be able to define the following terms. The terms are on the board, as you can see. We have distance, displacement, speed, velocity, acceleration, deceleration, or retardation. So we start by asking ourselves, what is linear motion? What is linear motion? Sometimes linear motion is known as rectilinear motion, and it's defined as a one-dimensional motion along a straight line. A one-dimensional, some people they call it 1D. One-dimensional motion along a straight line. The word linear means a straight line, motion in a straight line. Then it's divided into areas, namely kinematics and dynamics. Kinematics is a uniform linear motion with a constant velocity. Dynamics is a non-linear motion with a variable, a non-uniform linear motion with a variable velocity. The velocity varies, so it means acceleration. It's not zero, but with the kinematics, acceleration is zero. So let us define the first term. Our first term is distance. Distance is the actual length covered by a moving body. Distance is a scalar quantity, meaning it doesn't have direction. It has only magnitude, but with direction, no, it doesn't have. The SI unit of distance is meter. It's meter, abbreviated as small m. So sometimes when you're asked to state the SI unit of distance, you write in words. Just say the meter. Do not use a symbol. State there, you write in words. Our second term is displacement. What is displacement? It is a distance covered by a moving body in a specified direction. So this is a distance in a given direction. So this is a vector quantity because it's now having a magnitude and direction. The SI unit is also the meter. Let us illustrate the difference between distance and displacement. You can see there we have point A. We have a cyclist in point A, then point B, then point C. Then you can see between point A and point B, the distance there. Distance is 4 meters. From B to C is 3 meters. Then if a cyclist goes direct from A to C, that one will give us 5 meters. So at point B, the distance covered is AB. Small, AB without bold. They are not bold. Distance AB. While the displacement of the body is AB in the direction capital A, capital B, that is bold. They are in bold. distance AB bold. When it's handwritten, normally they are written AB on the top. The direction arrow is indicated. Then that is point AB. We are saying the distance AB between A and B, it's AB. But displacement, it is AB in the direction bold AB. At point B, point C, that is part B, distance covered, it will be the distance at that point from A to C. It will be AB plus BC. That is the distance. While displacement AC is displacement AC in the direction bold capital A and C. When you move back, say from B to A, at the starting point A, distance covered is AB plus BC. Then you move back, CA. Distance will be now be 4 plus 3, then back plus 5. But displacement, it will be 0. You started from point A to move to point C. But when you move back to point A, our displacement will be 0. You have to take that one into consideration. Our displacement will be 0. Our third term is speed. What is speed? Speed is the rate of change of distance covered by body. Speed is the rate of change of distance covered by body. The SI unit is meter per second. Meter per second, and it's a scalar quantity because it involves an element of distance. As you can see there, speed is given by distance covered over time taken. So for a body moving with a non-uniform speed, then we get average speed, which is total distance covered divided by total time taken. Our fourth term is velocity. Velocity. What is velocity? This is the change of displacement per unit time. It's the change of displacement per unit time. It can also be defined as the speed in a specified direction. It is the speed, the specified direction. Also, the velocity is a vector quantity because it involves the element of displacement. The SI unit of velocity is the meter per second. The meter per second. So the SI unit of velocity is the same as the SI unit of speed. But what is velocity? It's just sometimes people they say it's speed in a specified direction. So you can see velocity there is the changing displacement divided by time taken. For a body moving with a varying velocity, then we can get average velocity. Total displacement is given by total displacement divided by total time taken. So our fifth term is acceleration. This is the change of velocity per unit time. It is the change of velocity per unit time. It is a vector quantity. The SI unit is the meter per square second, abbreviated as MS raised by negative 2 meters per second, or meters stroke s. So acceleration is given by change in velocity or over change time taken, change in time. Acceleration is given by final velocity to subtract initial velocity or the time taken. So acceleration is abbreviated as A is equals to V minus U or over T, where V is the final velocity and U is the initial velocity and T is the time taken. Then I is the acceleration. So